Let's do some demand curve math to make sure we've got the basics down. We'll start with a pretty simple demand curve. The equation for our demand curve is just going to be 100 minus 20p. And you can see that our demand curve looks like this guy here. So let's say hypothetically that our quantity demanded increases by 20 units at every price. Let's think about what our new demand curve looks like, and then also let's think about what happens to our graph here. If we're going to increase our quantity by 20 units at each price, we can say that our quantity demanded becomes quantity demanded plus 20, in which case this is reasonably straightforward. And we can just say that our new quantity demanded is equal to 100 minus 20p plus 20, because we can just tack on a 20 to the quantity. And if we simplify this, we just see that this is quantity demanded is equal to 120 minus 20p. Conceptually, this change is a movement along the quantity axis, or the horizontal axis here, to the right of 20 units. So essentially, we're shifting the demand curve to the right by 20 units. Notice that a shift to the right by 20 units is not, in fact, equivalent to a shift up of 20 units. You'll see here, if we solve for price to figure out where our demand curve hits the price axis, rather than getting a price of 5, we get a price of 6. So we do indeed get a shift to the right of 20 units. But notice that this corresponds to a vertical shift of only 1 unit. So it's really important to understand that the horizontal distance between the old demand curve and the new demand curve, it does not have to be the same as the vertical distance between the old demand curve and the new demand curve. You'll notice that if we're just shifting the demand curve to the right by 20 units, the new demand curve is just parallel to the old demand curve. Therefore, if we said that the old demand curve had a slope of negative 1 over 20, the new demand curve also has a slope of negative 1 over 20. Notice that this slope is actually related to the ratio of the horizontal versus the vertical distance, because they are also off by a factor of 20. Let's do another example. Suppose now, rather than having a fixed increase, that instead the quantity doubles at every given price. Let's think about how the demand curve changes in this case. Again, it's fairly simple to do the math. You can say, well, if quantity demanded just becomes 2 times the quantity demanded, then we could just multiply our demand by 2, and we get the following. Again, we want to think about what this looks like on our graph in addition to what it looks like algebraically. So let's plot this. You can say to find our point on the p-axis, we set quantity demanded equal to 0 and we solve for p. So that's interesting because we had an intercept of 5 before. Now, even after doubling our demand, we still have an intercept of 5. If we think about our quantity axis intercept, now we have our intercept is 200, so we get a point that's somewhere out here. Connecting those dots, because we know that we still have a linear demand curve, we get the following. So now, rather than having a parallel shift, we actually have a pivot around this point here. Because we have a pivot rather than a strict shift, we actually do have a change in the slope of our demand curve. And we can calculate the slope of the new demand curve. We just say that the slope is equal to change in the y variable divided by the change in the x variable. In this case, it's negative 5 over 200, or negative 1 over 40. This shouldn't be surprising that we get negative 1 over 40 as opposed to negative 1 over 20, because our demand curve got flatter. Essentially what happened is our demand curve got stretched across the quantity axis. Let's do one more example. Now, rather than thinking about how our quantity demanded changes for every given price, let's think about how we can model changes in willingness to pay, or namely changes in price for any given level of quantity demanded. In this way, rather than talking about a horizontal shift or a shift along the quantity axis, we're going to be modeling this in terms of a vertical shift or a shift along the price axis. So how can we do this? Well, one way is to just go through and solve for price. We can do this by putting price by itself on one side of the equation and then dividing through by the coefficient on price to get what we call the inverse demand curve, which is price as a function of quantity demanded as opposed to quantity demanded as a function of price. Once we've solved for price, we notice that we can just say, well, for every price, if our willingness to pay increases by $5, we can just add 5 to that price. In that sense, so price is our old demand plus 5. Or simplifying a little bit, we just get price is equal to 10 minus 1 over 20 times the quantity demanded. You can then just go back and rearrange to see that our new demand curve is just quantity demanded is equal to 200 minus 20p. So let's think about how to graph this. As usual, we can just plot the different intercepts and see what that looks like. So here, if quantity demanded is equal to 0, that happens when price is equal to 10. So we get this point here. And if price is equal to 0, our quantity demanded is 200. So we get this point here. And we can just connect the dots. Notice that we get what we were expecting because our curve gets shifted up vertically along the price axis by 5 units. You can also notice here that we have an equivalent horizontal shift, just not by the same amount. We can see that the horizontal distance between the two curves is in fact 100. We can also see that we have a parallel shift, so if the slope of the old demand curve was negative 1 over 20, the slope of the new demand curve is equal to negative 1 over 20 as well. Notice again that the amount of vertical shift versus horizontal shift, they're not the same, but they are in fact related by the ratio of the change in y to the change in x, meaning that 5 is equal to 1/20th of 100. Now, our method for calculating this vertical shift is perfectly valid, but let's think about whether there's a more straightforward way that we could actually do this, rather than having to solve for price and then solve back for quantity. In this case, we could say the following. We could say the quantity demanded is equal to 100 minus 20 times some change in our price variable here. Whereas we just had price before, now we want to have some function of price here. Now it gets a little bit confusing because we're saying that the willingness to pay increases by $5. So it's a little bit strange that we would put in a p minus 5 here, but that's exactly what makes this work. You'll notice here, if we put in a p minus 5 in the original demand equation, and then multiply this out, we get exactly what we had the first time. Namely, quantity demanded is equal to 200 minus 20p. You just have to remember, if you're going to do this directly, that if you're increasing the willingness to pay, you need to subtract from p, and if you're decreasing the willingness to pay, you need to add to p. Just remember that it's backwards and you'll be fine.